Right, so we continue. So the other value of x here we found is 3 pi by 4, but 3.
That is 135.
Yeah, it's 135, yes. So it's in the range. So it's also value of x. Let's continue.
So this question will not get anything.
Huh? Where? Where should I repeat? Hello, that one asking a question. Where should I repeat?
No question.
The whole question.
For now, you're finding the values of x.
For now, you're finding the values of x. Okay. Okay. So the values of x. So we're being asked to say, we have been given this. Oh, sorry. So you have sine 3x being equal to 0.5. So you're being asked to find the possible values of x for which this equation will hold. Then they've told you to say your x should be in that range from 0 to pi, between 0 and pi to say. So you have sine 3x being equal to 0.5. This is a positive number. So you suspect your sine x is positive where and where. So it is positive in the first and second quadrant. Are we together? So for this one now, you know that this is just the same as half. 0.5 is half. And you know where your sine of x equals 1/2. What are you going to get? So you know that x there is equal to 30 degrees. But it is also positive in the second quadrant. You have to find the other angle in the second quadrant, which will be, you just subtract this from 180. Then you get 150 degrees. For this one, now you come back to this one. So you're going to say, okay, sine 3x is equal to 0.5, which is half. Then you know that one value of 3x, which for which this one will hold, is 30 degrees in the first quadrant. So you say 3x is equal to, say, sine inverse of 0.5, maybe. So that would be 3x being equal to 30 degrees. Then x, you divide both sides by 3 there. X will give you 10 degrees. Do you know what that means? You have, when you go back to your expression here, you have sine 3x. What is that equal to? So you have 3 times 10. So you have sine 30 there. What is your sine 30? You get a 0.5 on the calculator. You also try sine 150 on the calculator. You also get 1/2. So that's what we mean. So for the other value, you have 150 degrees. So you have sine 3x being equal to 0.5. Then you have that your 3x in this case is equal to 150. 3x is equal to 150 degrees. Then your x is equal to, you divide both sides by 3 to get 50 degrees. Then you do the same with the other one. So in radians, you can just say, okay, this is, you know, your 180, you know, your 30 and your 180. Your 180 is pi. Then your 30 is minus pi by 6. This is 6 minus pi. You're getting 5 pi by 6. So that's what you have. So for the other one, 225, for tan x plus pi by 2 being equal to 1. We said this one is positive in the first quadrant and in the third quadrant. So you need to find, so in the first quadrant, it's 45 degrees. And in the third quadrant, you discover that it is simply pi plus pi by 4. Of which you're going to get, this is 4 plus this one, you have 5 pi by 4. And then you subtract, so this one is pi by 4 there. So you subtract minus pi by 2 there, minus pi by 2 there, you get your desired results. I hope it's clear. Right.
Yes,
Yes,
it
sir.
is.
Yes.
Yes. So let's move on to the next question. Now we are going to talk about sketching the graphs of trigonometric functions. Before I start sketching, I want us to look at this. So you know the basic trigonometric functions, like, you know, there's f of x is equal to sine x. There is, say, f of x is equal to cos x. There is also f of x is equal to tan x. Those are basic trigonometric functions. And you know, for this one, we are going to sketch these graphs in the range of, say, from, say, okay, minus 2 pi to 2 pi. So you want to see what happens in this range for this graph. So it's like, what you're doing is this. So you have a point here, it's moving from here to there. So you want to see what is happening with this, the radius, this triangle here. So you want to see what is happening with the sides. We are going to talk about them in terms of the graph. So there's an angle, it moves from 0 all the way to there. And what happens when it moves from 90 degrees to 180 degrees? And what happens when it moves from there up to there, then again to 360. So you can talk of this from here, the other way around. So you can talk of it clockwise and anti-clockwise. So having said that, you know, the sine function has a graph that looks something like that. So you have your x there and your y. So you know your x are going to be the angles, and then your y, the values of the functions there. Right. So let's say this is 0 degrees. Then let's talk about the quadranatal angles. Say 0 degrees. Then you also have pi by 2, which is 90. Then you have pi, 180. Then pi plus pi by 2, going to get 3 pi by 2. Then again, you get all the way up to 2 pi. So the same thing will happen here. So you have pi minus pi by 2 minus pi. And then you have minus 3 pi by 2 there. Right, so let's consider this one. So when x is 0 degrees there, you know the behavior of a sine function when x is 0 there, you see it is also 0, so it starts there. Then it increases up to when x is pi by 2, you see that the sine function is 1, so it's going like that. So up to 1 there, then it goes like that. Then at pi again, it's 0. Then at 3 pi by 2, it's 1, -1 there. Then it will go, and then it comes like that to 2 pi where it is 0 as well. Then the same thing will happen the other side. Okay, like that. So that is the basic, the graph of this basic trigonometric function. So it has amplitude 1. So we're going to talk about that. That's it. And then for the cosine function, you see, okay, let's do it on the same one. So this is sine x. And then for the cosine function, you know the behavior. When x is 0, it's 1, so it will go there, and that is the furthest it will go. When it's pi by 2, it's 0, so it will go like that. At here, 0, then there it's 1. The same thing will happen the other side, like that. Then you are there. So that is your cos x. Right, so let's look at question . I think we can do 1 or 2 questions, then we'll close fast. Oh yeah. So question 7, sketch the graphs of the following for x between 0 and 360 degrees. Right, so we want to see what is happening to this graph. So you have the first one, y is equal to minus cos x. Okay, I'm going to do 3, 1, and 3, then the rest, the other ones, you can try them out. So you're going to do y is equal to 1 plus cos minus 2x. So sketch the graphs. All right. So you have y is equal to cos x, and y is equal to 1 plus minus 2x. So before we go there, we can say let f of x equal to a, say sine B, then X plus C. Then we can bring out the following. This A, the modulus of A, is called the amplitude of the function. The magnitude from the x-axis to the apex of the function there. Then you have B. B is called, we're going to discover later. Then you have what is called the period of a function, which is given by 2 pi divided by your B. And then you have your C, which is equal to, oh, forgetting something here. Let's say plus D there. Then you have your C here. That is seen as your shift. The shift, the horizontal shift, the shift in the x-axis to say. And then your D is seen as your vertical shift. Remember, for the first shift, when it is positive, then the movement is to the left. And when it is negative, the movement is to the right. So let's look at this one here. Y is equal to minus cos X. So guys, here things are very simple. You know the graph of the basic trigonometric function, this basic trigonometric function, you know, it's like this. So that is your Y, that is your X. But you know, you've been given to say for X in this range, from 0 to 360. So you know the graph of this one here starts from here. So when it's 0, starts from 1, and it goes through pi by 2, then pi, you have 3 pi by 2, all the way up to 2 pi. So it starts from here, it goes like that. Then again, then it goes there up to 2 pi. That's -1. So what is happening? This is the graph of cos X. But you've been taught to graph to sketch the graph of negative cos X. So what will happen here is that the negative values of cos X will become the positive values of cos X. I mean, the positive values of negative cos X will become the negative values of that one, the other one cos X, and vice versa. So this one is just that it's been shifted like that. So it's been transformed upside down. So this one will start from, instead of starting from 1, it will start from -1, going like that. Then up to there, then it will go like that. Then it will come, well, it's 1 there. So the graph of Y is equal to minus cos X is that one there. So say Y is equal to minus cos X. All right, I think it's time up. We can end here, then we can continue from our question. So let us not delay those that are going for class. So we have, right, everyone. us meet in the next meeting.